In this video lecture, I would like to discuss about the non-instrumental experiment, that is chemical kinetic. So this is the fifth experiment, belongs to the TYBSc Physical Chemistry Practical Examination. So in chemical kinetics, generally we determine the rate constant of the reaction. But in this experiment, we are going to determine the order of reaction. So let us see what is the aim of the experiment: to determine the order of reaction between potassium persulfate and potassium iodide by fractional change method. So in this experiment, we have to determine the order of reaction. So what is the order of reaction? Order of reaction, it is related to the concentration of the reactant. It means the order of the reaction can be determined according to the rate of the reaction, which is dependent on the concentration of the reactant. Suppose if the rate of the reaction, it is dependent on the concentration of the two reactants, then the order of reaction is 2. If the rate of the reaction is depends on, so order of reaction, it is the rate of the reaction dependent on number of reacting molecules. If the rate of the reaction, it is dependent on the two reactants, then the order of the reaction will be 2. So in this case, the rate of the reaction is dependent on the two reactants, but we want to determine this. So for this experiment, what we require? We require the reagent bottles. We require the two important solutions, that is zero point 0.05 normal potassium persulfate K2H2O8. We require 0.05 normal potassium persulfate, 0.05 normal potassium persulfate, and 0.05 normal potassium iodide. The third solution we require, that is 0.02 normal sodium thiosulfate solution, and the starch indicator is also required, and we require the ice also for the purpose of the titration. So let us see what is the theory behind with this experiment. In this experiment, the potassium persulfate reacts with Ki. Potassium persulfate oxidizes Ki to liberate iodine. So when the reaction between potassium persulfate and I2 takes place, the iodine is liberated there. So you can see here the reaction is shown here between potassium persulfate and potassium iodide. So potassium persulfate reacts with potassium iodide, and there is a formation of the potassium sulfate and I2. So I2 is liberated here. Now the progress of the reaction is studied by titrating the liberated iodine against sodium thiosulfate solution using freshly prepared starch solution as an indicator. So when the liberated I2, it is titrated with sodium thiosulfate solution, this reaction will be takes place. So whatever the iodine is liberated when the reaction is going on, that I2 is titrated against the sodium thiosulfate solution. So in this reaction, both the reactants are involved. So rate of the reaction supposed to be dependent on the concentration of the two reactants. Okay. Now the order of reaction is determined by studying the reaction between potassium persulfate and Ki using fractional change method. and using equimolar concentration of potassium persulfate and Ki. So suppose if we take 0.05 molar potassium persulfate, then Ki it is also 0.05 molar. So their concentration it is equal or equimolar concentration. So fractional change method we are using here. Now you can see the equation belongs to the fractional change method. It is given here. The order of the reaction can be determined according to this. N it is equal to 1 plus log of T1 minus log of T2 divided by log of A2 minus log of A1. So using this equation we can determine the order of the reaction. And the values T1, T2, A1, A2, or the another equation we can use here, 1 plus log of T1 minus log of T2 divided by log of x2 minus log of x1, where x1 and x2 are the amount of the reactant reacted. So x1 and x2 can be determined according to the graph. So let us see how to perform this experiment. So this experiment can be performed in two sets. This experiment can be performed in two sets. So see here the first set. So in the first set, 50 ml of 0.05 normal potassium persulfate is taken into the bottle number 1, and 50 ml of 0.05 normal potassium iodide is taken into the bottle number 2. And we have to keep the two bottles in the water bath to attain the room temperature. In the first bottle, we have to take this 50 ml of 0.05 normal potassium sulfate, potassium persulfate, and in the another bottle we have to take 0.05 normal potassium iodide solution. And we keep these two bottles in the water bath to attain the room temperature. So after some time, we have to mix these two bottles, and we should have to prepare the reaction mixture. According to this, we can prepare the reaction mixture. Once the reaction mixture has been prepared, we have to note the time. So mixing time is very important here. So after the 5 minute, we have to withdraw the 10 ml of the reaction mixture from the 10 ml of the reaction mixture, and we should have to titrate that 10 ml of the reaction mixture with burette solution, and burette solution it is 0.002 normal sodium thiosulfate solution. So already we filled this solution in the burette, and we take 10 ml of the reaction mixture after the 5 minute of the mixing time, and we have to titrate this solution. And a starch indicator is also added here in the conical flask. So the end point of the titration, it is blue to colorless. And we have to note that burette reading after the 5 minute interval. Similarly, we have to perform the second set. So in the second set, just we have to take the 25 ml of 0.05 potassium persulfate. In the first set, we have taken 50 ml. Now in the second set, we have to take 25 ml of this potassium persulfate and 25 ml of the water. So concentration will be reduced to half as compared to the set 1. Similarly, we have to take 25 ml of the 0.05 normal Ki solution in the another bottle, and we have to add 25 ml of the water. So again the same process we have to repeat. Keep the two bottles in the room to attain the room temperature in the water bath, and we have to prepare the reaction mixture. After some time, we have to mix these two bottles, and we have to prepare the reaction mixture. Okay, and after the interval of time intervals of 5, 10, 15, 20, 25, 30 minutes, we should have to take 10 ml of that reaction mixture in the conical flask, and some starch indicator should be added there, and that reaction mixture it is titrated with the 0.02 normal sodium thiosulfate solution. So this is the experimental part can be performed in the two sets. So let us see the observation table here. So we can record the observations in the given table. Set 1, A it is equal to B it is equal to 125 ml. That is the concentration, initial concentration of the reactant. So time it is in minutes. So after interval of 5 minutes, we have to take the reading here. So that is x, a minus x, suppose a it is 125, so x suppose it is 4.0, so a minus x it is equal to 125 minus 4. Okay. So let us write that reading here. Suppose we get the first reading 4.0 ml. Okay, so a minus x it is equal to 125 minus 4, it is 121, and next table it is 1 upon 121. So we should have to do the calculation. After 5 minutes again we have to note the other reading. Suppose that other reading will becomes equal to 5.5, like that. So similarly we have to perform the calculations here. Okay, so this is the observation table for set 1, and this is the observation table for the set second. In the set second, as the value of the A is equal to 62.5 here, and actually the concentration is half as compared to the set 1. So second set readings are comparatively half to that of the set 1. So supposed to be it is 2.0 here, like that. So in this way we can take the readings, and we have to fill this observation table. Let us see now the calculation part. For both sets we have to plot the graph. The graph, which graph? 1 upon a minus x against t. Onto the y-axis we have to take 1 upon a minus x, and onto the x-axis we have to take time t. So okay, 1 upon a minus x versus the time t, and according to this we can determine the rate constant k. So in this experiment we have to determine the rate constant also by plotting the graph. So rate constant k, I think k it is equal to 2.303 into slope. Okay, k it is equal to 2.303 into slope here. So by plotting this graph 1 upon a minus x versus t, we are getting the k value here. Then second calculation, for both sets we have to plot the graph. So it means that two graphs for both the sets. Then determination of the order of the reaction. This is our main calculation. So for this purpose, we have to plot the graph of x against t for both sets, and determine time t1 and t2 in minutes to complete the half of the reaction. And according to this, we have to determine the order of the reaction according to this formula, according to this equation. So t1 and t2 can be determined from the graph. Similarly, x1 and x2 can be determined from the graph. So you can see the graph here. This is the graph of x versus t. This is the graph of x versus t. Okay, onto the y-axis we have to take here x, and onto the x-axis we have to take here time, 5, 10, 15, 20, 25, 30. So on the same graph we have to plot the two sets. This is for suppose set 1, this is the graph, and this is the graph for set 2. Okay, so the x value should be taken here onto this. X means burette reading on the y-axis, and time t should be onto the x-axis. So you can see here, with the help of this first like this curvilinear type of the nature of the graph. So we are getting here the x1 value. Okay, so corresponding to the x1, the t1 value should be here, whatever the t1 value here. So you can see here it is around supposed to be 11. Okay, it is around supposed to be 11 here, and x1 value should be around 4 ml here. Then similarly for the second set, we have to take the x2 value here 2 ml, and t2 value it is around 25 ml. So with the help of the x1 x2 values and t1 t2 values, by putting that values into this equation, we have to determine the order of the reaction. And after the calculation we are getting the order of the reaction becomes equal to 2, because this is a second order reaction. Rate of the reaction, it is dependent on the concentration of the both the reactants, potassium persulfate as well as Ki. So when we are putting the values T1 T2 according to the graph, similarly x1 x2, you can see here this is x1, and similarly x2 and T1 and T2. So with the help of this, we can determine the order of the reaction N, and we have to represent the results in this tabular form. We have to represent the results in the tabular form. So see here, temperature, whatever the room temperature is given there, suppose that it is 298 Kelvin. So we have to notate that. So rate constant K1 for set 1. Similarly, rate constant K2 for set 2. According to this graph, we have to determine the rate constant here. Similarly, K2 we can determine from the second graph, and we have to write this is the unit of the rate constant, decimeter cube per mole per minute, and final calculation it is order of reaction. So in this way, in this experiment, we can determine the rate constant K1, K2 and order of reaction. So for both the sets, the rate constant values we are getting here, K1, K2, and order of reaction we can also determine. So in this way, we can perform this experiment. We can determine the order of the reaction according to the reaction between potassium persulfate and Ki.